Good day, I'm Dr. Paul. Today I'll be talking about determining oxidation numbers. What is an oxidation number? An oxidation number can be defined as the apparent charge of an atom in a molecule or ion, or simply the charge of an atom if the pair of electrons in a covalent bond was assigned to the atom of the more electronegative element. Oxidation number can also be referred to as oxidation state. What are the importance of oxidation numbers? Oxidation number help in balancing redox reactions. It also helps in identifying oxidizing and reducing agent in redox reaction. It helps in determining the number of chemical bonds that can be formed by an atom. And then it helps in naming inorganic compounds. Very important. Now let's look at the rules for assigning oxidation number. The oxidation number of any uncombined element is 0. Rule number 2. The oxidation number of a monoatomic ion equals to its charge. As you can see on the slide, the oxidation number of sodium is 0. That of chlorine is 0 because it's uncombined. But if you look at the product side, the oxidation state of sodium is +1, while that of chloride in sodium chloride is -1. Rule number 3. The oxidation number of oxygen in compounds is -2, except in peroxide such as hydrogen peroxide where it is -1. The oxidation number of hydrogen in compounds is always +1, except in metal hydrides like sodium hydride where it is -1. If you look at water molecule, hydrogen is +1 while oxygen is -2. The oxidation or sum of the oxidation numbers of the atoms in a compound must equal to 0. If you look at the slide, the total oxidation number of water should be equal to 0, looking at the charges, while for that of calcium hydroxide, it is also equal to 0, looking at the charges. Calcium is +2, while the hydroxide ion is -1. When you multiply it by the 2 subscript, you get a charge of -2. So +2 -2 will give you a total charge of 0. The sum of the oxidation numbers in the formula of a polyatomic ion is equal to its ionic charge. If you look at the nitrate ion on the slide, it has a charge of -1. So the oxidation number or total oxidation number or oxidation state must be equal to -1. When you resolve the operation, the oxidation state of nitrogen will be +5 in the nitrate ion. For the sulfate ion, it has a charge of -2. So if you resolve the operation to look for the oxidation state of sulfur, the oxidation state of sulfur in that compound will be +6. So the sum of the oxidation numbers in the formula of a polyatomic ion must be equal to the charge the ion is carrying or the polyatomic ion is carrying. Let's look at reducing agent and oxidizing agent. Whenever there is an increase in oxidation number, we say that oxidation has taken place. While whenever there is a decrease in oxidation number, we say that reduction has taken place. If we look at the first half equation, sodium moved from the oxidation state of 0 to +1, which is an increase in oxidation state. That means sodium has been oxidized and it is therefore a reducing agent. When we look at the second half equation, chlorine moved from the oxidation state of 0 to -1, which is a reduction. Therefore, chlorine is reduced and it is termed as an oxidizing agent. So, reducing agents are oxidized in a reaction, while oxidizing agents are reduced in a redox reaction. Let's consider calculating the oxidation number of some elements in a compound. The first one is potassium tetraosochromate 6. If you look at the compound, potassium has an oxidation number of +1, while chromate will be regarded as X because we are looking for the oxidation number of chromium. Oxidation number of oxygen is -2. So when we resolve the operation on the slide, we get chromium having an oxidation state of +6. Therefore, we call it potassium tetraoxochromate 6. The 6 in the formula or the name is derived from the oxidation state of chromium in that compound. For the iodate ion, the oxidation state of iodine is not given, while the oxidation state of oxygen is -2. When we resolve the operation, we get an oxidation state of +5. So the compound is called iodate ion, with iodine having an oxidation state of +5. Next is H2S2O7, called disulfuric acid. If we are to calculate the oxidation state of sulfur in this compound, you will discover that it is +6. Oxidation state of hydrogen is +1. That of sulfur is not given, so we call it 2x because of the subscript 2 underneath sulfur, while the oxidation state of oxygen is -2. When we resolve the operation, we'll get +6. To calculate the oxidation state of phosphorus in phosphoric acid, H3PO4, you discover that the oxidation state of hydrogen is +1. That of phosphorus was not given, so you call it X, while that of oxygen is -2. When we resolve the operation given, you discover that the oxidation state of phosphorus is +5. Do take out time to calculate the oxidation state of the given compounds on the slide. Thank you.